if I'm understanding you correctly, sort of my read of what you've said in this whole thing is that beta amyloid plaques tend to precede the tauopathy that seems to be particularly important to Alzheimer's. But what causes the tauopathy is increased activity of these kinases that hyperphosphorylate the tau protein. And one possible initiating factor of that kinase activity going up is amyloid beta plaques. But I would imagine logically speaking, that's probably not the only way that can happen. There might be alternative ways that can happen.
Right. So there's also evidence suggesting that inflammation in the brain can initiate these kinases, right? So going back to the primary tauopathies, frontotemporal dementia, talking about chronic traumatic encephalopathy, you usually see tau proteins that build up there, and there's really no evidence of amyloid beta being present. So yes, the question is, why is that? And what we're finding is that with, for example, the example of CT is a good one, chronic traumatic encephalopathy, that's typically triggered by repeated head blows, right? Traumatic brain injuries. And we know with those injuries, you typically have inflammation that is elevated in the brain and chronically elevated. So there is evidence actually now showing that having increases in inflammatory molecules in the brain can actually lead to increases in those kinases as well that can then initiate the hyperphosphorylation and those neurofibrillary tau tangles. Yes.
I see. So if we think in like a 2x2 grid here, tau protein present, absent, beta amyloid plaques present, absent. It sounds like in almost all cases of Alzheimer's, when you do the autopsy, you're going to find both tau and plaques, but perhaps in a minority of cases, you find the hyperphosphorylated tau and the tangles without plaques because it was caused by some other thing. And you're essentially never going to find, you might find, an absence of the plaques, but you're never going to find pathology in the absence of tau. And you're usually not going to find it in the absence of plaques, but sometimes you will.
Yeah, I mean, I think that's a nice summary, and that really, highlights the complexity of these diseases, right? That some of them are initiated by an aberrant, protein like amyloid beta, and some of them are by the inflammatory molecules because of repeated head traumas and that sort of thing. But I think the point here that I want to make is that it goes back to the general premise that ultimately the tau tangles is what you really see that drives a lot of these different clinical symptomologies, right? But the evidence with that's being put out there now tied to the therapies that actually target amyloid beta, right? Like lecanemab, that's now clinically approved. Their hypothesis is that if we halt the amyloid pathology, that can lead to a halting of the actual tau pathology, right? And there's actually some evidence of that. If you look at a presentation that was given by Biogen in 2024 at the Alzheimer's conference, they actually show that individuals that have been on lecanemab now, this antibody therapy that essentially tags the amyloid beta plaque for degradation, they actually also show some signs of decreases in tau pathology as well, right? In these Alzheimer's cases. Yeah. So I think that points back to the fact that the amyloid beta plaques likely are initiating a cascade of events tied to the tau pathology, whereas you can also get the tau pathology due to other insults like the traumatic brain injuries. Yeah.
Got it. So what seems to be really key here is something, which can often be the beta amyloid plaques, but it could be other things, but something is going to trigger kinases to become more active and hyperphosphorylate the tau protein. That's when you really start to have a problem. Thinking ahead to some of the other stuff that I know that you work on that we're going to talk about, you mentioned traumatic brain injury. You could just get, blunt force trauma, which triggers inflammation that could start to initiate this hyperphosphorylation process independent of, say, beta amyloid plaques. I would imagine that in theory, at least, there could be, say, chemicals or toxins in the environment that might upregulate kinase activity and lead to the same result. What do we know about possible environmental toxins that might tie into Alzheimer's disease?
Yeah, there's a lot of evidence coming out now, looking at various plastics and how plastics that might actually migrate into the gut microbiome. There's a lot of connection between the gut microbiome and the brain. May actually show up in the brain. These plastics might show up, and we know that anything foreign that has the ability to cross the blood-brain barrier, right? Blood-brain barrier, you can think about it as vasculature that has a variety of barriers preventing things from getting into the brain. Because what you want to do is you want selective things to get into the brain, chemicals, compounds into the brain, because if they're pathogenic, for example, or they're viruses or pathogens that can actually harm the neuron,